Assalamualaikum and greetings to all. Okay, let's continue with example 8, where here we are given Cartesian triple integrals and we are asked to evaluate this by using spherical coordinates. So here we need to change from Cartesian to spherical. Okay, the reason why we want to do that is because it's going to make our evaluation easier compared to evaluating the triple integrals using Cartesian. Okay, first step is we're going to change the integrand. Okay, so the integrand involves x, y, z. Okay, so for z in spherical, it's rho cos phi. Okay, we need to square this. And then x squared plus y squared plus z squared is rho squared, but then we take the square root of that. And dz dy dx is really dv. Okay, so dv in spherical is rho squared sine phi d rho d phi d theta. Okay, now I'm just gonna put g first there. Okay, now we're gonna figure out our solid g. And to sketch our solid G, we just need to get the limits for x, y, and z. Okay, let's see here. So the inner integration is with respect to z, which means that negative square root of 4 minus x squared minus y squared and z equals 0 are the limits for z. Okay, let's write those two equations down. Okay, so the upper limit for z is z equals square root of 4 minus x squared minus y squared. Now when you look at this equation here, we know that z is larger than or equal to 0 because the root given here is a positive root, no negative there. Okay, all right. If you can't tell the shape of the surface yet or the curve, let's do some manipulation by getting rid of the square root. So to do that, we need to square both sides. So when you square the left hand side, we have z squared, and when you square the right hand side, we end up with this. And now rewriting the equation, we get x squared plus y squared plus z squared equals 4. And I think you recognize that equation. That equation represents a sphere. It's a sphere where the radius is 2 and the center is at the origin, 0, 0, 0. And if you want to change this to spherical coordinates, on the left hand side it's rho squared, on the right it's 4. So simplify that, we get rho equals 2. So the equation of the sphere is rho equals 2. But remember, the original upper limit for z is positive, larger than or equal to 0, which means that we don't take the whole sphere. We only take the part where z is positive. That would be the upper hemisphere. Okay, and the lower limit for z is z equals 0. Z equals 0 is just the xy plane. So as of now, we know that our solid, from using the upper and lower limits of z, we know that we have an upper hemisphere where we have z equals 0 or the xy plane as our lower limit for z. Okay, let's sketch that. So here we have y-axis, x-axis, and z-axis. Okay, we have upper hemisphere, so this represents an upper hemisphere. So this is upper hemisphere. We don't take the whole sphere. All right, the radius of the sphere is 2. So let's say this is a 2. A 2. See, that's a 2. That's a negative 2. And here we have a 2 as well. So we only sketch the upper hemisphere because we have the lower limit is z0. So another name for that, even though we only take half of the sphere, the equation of the sphere is still rho equals 2. Okay, so that is using upper and lower limits for z. Okay, now let's look at the limits for x and y. Okay, so here we have, alright, I'm gonna erase this so that I don't have to change pages. Okay, the upper limit and the lower limits for x and y. Okay, let's look at x here. Okay, x is the outer integral, so 2 and -2, those are limits for x. So upper limit for x is 2, lower limit is -2, and here we have y is, the upper limit is this, and the lower limit is negative. Okay, now if you don't recognize what that is, we can always do some mathematical manipulation by squaring both sides. So we have y squared equals 4 minus x squared, and if you do this, it's the same thing, and rewriting this, you get a circle of radius 2 centering at 0, 0. Okay, and then that means for the upper limit of y here, that is the upper circle, the top part where y is positive, and this is the bottom part of the circle. Okay, so if you sketch this in 2D on the xy plane, so we have let's change it to green. So this is a positive root, y equals square root of 4 minus x squared, and at the bottom we have y equals negative square root of 4 minus x squared. So this is 2, -2, 2, -2, and then the limits for x is from -2 to 2, meaning that we take the whole circle, which means that this would be our the whole solid G. Okay, so that is our the whole solid G. Right, I'm gonna erase that line there. So this is our solid G. Okay, so now we're gonna evaluate or get the limits for our triple integral. I'm going to copy this to the next page. Alright, so here we have paste. Alright, so now let's get the limits for rho, phi, and theta. Okay, so the integrand is still the same. Alright, we can simplify this. How many rows do we have? Here we have rho squared, that would be rho, and that would be rho squared. So we have 5 rows. 2, 3, 4, 5. Okay, and then we have cos square phi. Oh, that's too small. Square phi, and we have sine phi, and the order is d rho, d phi, d theta. Okay, let's get the limits for rho. Okay, just refer to the solid G here. This is our solid G. Alright, to get the limits for rho, remember rho, we measure from the origin and then draw a straight line across your solid. As you can see, it does start at 0 and then it stops on the blue sphere, which is represented by 2. Okay, so the upper limit for rho is 2, lower limit is 0. Okay, now let's get the limits for phi. Remember how you measure phi. To measure phi, you measure it from the positive z-axis, and then you can do it this way. Okay, and then you can see that it stops on the xy plane, or you can measure it this side. It starts on the positive z-axis and then it stops on the xy plane. So the angle there is pi over 2. Okay, so the limit for phi is from 0 to pi over 2. And the limit for theta, well, you can see, you can refer to the solid G, or you can refer to your xy plane. You can see that we have a 1 whole rotation there. So theta is from 0 to 2 pi. Okay, now if you compare this triple integral in spherical with the original triple integrals in Cartesian, you can see that this is so much easier to evaluate. As you can see, all the limits are from a constant to a constant, and here we have all these square roots, which is harder to evaluate. Okay, that's the reason why we change from Cartesian to spherical. Okay, let's evaluate this. Alright, so we have 0 to 2 pi, 0 to pi over 2. Okay, let's integrate with respect to rho first, which means that cos square phi and sine phi here is considered as constant. So integrate a rho to the power 5, we have rho to the power 6 over 6, and then replace row with upper and lower limits. So we have 0 to 2. We still have d phi d theta. Okay, 2 squared is, let me see, 2 to the power of 6 is 64. Okay, divided by 64 divided by 6 will give us then 2 over 3. Okay, let's put it here. Then we have 0 to 2 pi, 0 to pi over 2, cos square phi sine phi d theta. Okay, now we're gonna integrate with respect to phi. So we're gonna use substitution method. We're gonna let u as cos phi, which means that du is negative sine phi d phi. Okay, so here we have 32 over 3. Some of you, once you have the limits, have no problem evaluating this. So here we have u squared. Sine phi d phi will be replaced by negative du. We still have d theta. Now, if you don't want to change u back to cos phi, we can always use the limits for phi to get the limits for u. Okay, so here, the upper limit for phi is pi over 2. So when phi is pi over 2, cos pi over 2 is 0. So that would be the upper limit for u. Lower limit for phi is 0. Cos 0 is 1. Should be u is 0. Here u is 1. So the lower limit for u now is 1. Okay, so now, oops. Now let's evaluate this. Okay. I think I need more room. Let's erase this bit here. Okay, integrate u, if you don't like the negative, we can put it here. Okay, and here we have 2 pi. Integrate u squared, we get u cubed over 3 from 1 to 0. Okay, so that will give you negative 32 over 3, 0 to 2 pi. So here we have 0 minus 1/3. Is that right? And then here we have d theta. So 1/3 times negative 32 over 3, that will give us 32 over 9. Okay, and then we still have d theta, 0 to 2 pi. Okay, integrate d theta, we get theta, 0 to 2 pi. So that will give us 64 pi over 9. So that's the answer to example, what is that? Example 8. Okay, all right, thank you.